Hello everyone. In this video, I'm going to go over some inequalities. It's just going to be basically linear inequalities and quadratic inequalities. First of all, what's an inequality? It's just we have four symbols. It simply stands for greater than or equal to, less than or equal to, less than or greater than. And in an equation, once you replace the equal sign by an inequality symbol, then that becomes an inequality. So it's like the same format. For example, some examples, there's no equal sign, there's all inequality signs in here. And the point is that we also have the terms linear, quadratic, cubic, all that kind of similar stuff from the equations. So if the power of x is 1 with constants as coefficients, then that becomes a linear inequality. So for example, this one is a linear inequality. This is linear inequality. This is like non-linear because of x squared. Okay, actually you can just say that's quadratic, and yeah. So when we say a linear inequality, it's just the same thing. We have x and power of x is 1, and we have constants as coefficients, and we also have constants added or subtracted. Now the point is that it's just same as the equations. You may add the same number to both sides, or you can subtract the same number from both sides. These are some properties. These are some examples. So you can add or subtract the same expression or same kind of constant from both sides, or you can add. But the point is that if you multiply both sides by a positive number, it's still the same. But there's one important kind of property of inequalities. If you multiply or divide by a negative number, that's a little bit different. In that case, the direction of the inequality will be reversed. So for example, a is less than b, and you multiply that inequality by a negative number, then that less than becomes greater than. So it's just simply reversed. You will see that in examples. And next, briefly, we can go over the interval notation. What is that? It's kind of like you use a bracket if the number is included within the interval, or a parentheses if the number is not included. For example, in the first case, if you look at the number line, we use close points. 3 and 5, both of them are included, and you take the numbers between them. So it's like 3 and 5. That's how we represent. If you have parentheses though, in that case 3 and 5 are open. That's or sometimes they can just put this as like parentheses like that, in the same way as an interval, and take the numbers between them. Here we go. It's like 3 and that's like 5. This is for that one, this is for that one. And also there's another one. If you have infinity symbol, that means it's not included because infinity is not a number. But for example, when we say the value is greater than or equal to 2, we represent 2 with a bracket and infinity with a parenthesis. So that really represents, this one represents all the numbers including 2 and the ones after 2. So this side is infinity, that side is 2. So in a similar manner for this one, you can just say that's negative infinity is on the left side and 2 is on the right side. And you take all the numbers less than 2, and 2 is an open circle. So I hope this part is clear. That's kind of like a review of the parentheses interval notation. So there's a bracket if the point is included, and parentheses if the point is not included. So and also we have a yeah, this is kind of like how we work with the intervals. So now let's continue with some examples. So like these two problems. In the first one, it's really simple. You try to collect the variables into one side and the constants into the other side. So I can add 4x to both sides in here, and then you can subtract 1 from both sides. I can do it at the same time, so these two will cancel and these two will cancel. So on the left side I have 5x, and on the right side that's greater or equal to 5. That's a now you will divide both sides by 5, and that's a positive number, so the direction will not change. These two cancel and these two cancel, you get 1. So we got x is greater or equal 1. So 1 is included, and we take all the points after 1, including 1. So that means we need to use a bracket. So here the solution set will be 1 comma infinity. So that's the solution set for this problem. Now let's move to the next problem. See, you need to get rid of the fraction, so you can multiply both sides by -10. So let's just multiply both sides by -10. And in this case, this number 10, -10, this is negative. So that means you will reverse the inequality. So that's what you need to do. So which means, like, these two will cancel. That's right, you got x plus 5 on the left side. On the right side you got -20x minus 30. It's greater than, now you will make it less than. Please just be careful with that. The direction is now reversed, and then you solve it in the same way now. So I add 20x to both sides so that these two will cancel. So I have 21x plus 5 is less than -30, and then I subtract -5 from both sides. See, it's the same as solving an equation. So these two cancel, and I got 21x is less than -35, and the final step I divide each term by 21. And you see these two will cancel, and that will simplify to, you can divide both of them by 7. So that will be -5/3. So you can cancel those to simplify. So what we get is, at the end, is we got x is less than -5/3. See, it's less than, and it's like -5/3 is not included, so that's going to be kind of, I have here -5/3, and I need to take all the ones less than that, and that side is -infinity. So the solution set for this problem will be simply -infinity comma -5/3. So that's the solution set for this problem, and I hope that problem is clear. Now, next problem, I want you to try it yourself first, and then I will just go over the solution. The next problem is like, let me write this down. So I want you to try this problem. 3x minus 1 is greater than 2 times x minus 3 plus 1. This problem. Can you just pause the video and work on this problem for a couple minutes? Okay, so let's continue. Now let me delete this because that's like the next problem in here. So now you can check this problem. So the point in this problem is that it's the same linear inequality, but this time you need to distribute that 2, and then you combine it. You solve it like a linear equation, but you keep, there's nothing that you divide or multiply by negative numbers, so the direction still is same. And at the end you got x is greater than -4, so the solution set becomes -4 comma infinity. Okay, so let's next go into compound inequalities. So in a compound inequality, you have the word and or, but we're really going to stick with the simplest one. So you have like 3 parts in an inequality, and you work it in the same way. If you multiply it by a negative, you switch the directions and all that kind of stuff still works. But the point is you now have 3 parts. That's the only thing. So for example, why is that helpful? I'll solve an example application. You will see it will be really helpful in that. But the point is that you combine multiple inequalities, and it's called compound inequality. For example, you want to solve this one. Your aim is to isolate x. So you try to isolate x. So what I will do is you can simplify, you can subtract -1 from each. So that will make it -6 less than or equal 2x less than 39. And then you divide all the 3 parts by 2. So that these 2 will cancel. See here, 1 will cancel. So you got -3 less than or equal x and less than 39 over 2. So that makes x between -3 and 39 over 2. So I can write down the solution set easily. So the solution set in this case will be -3 with a bracket and then comma 39 over 2 with a parentheses. So it's kind of like that. 39 over 2 is a parentheses because it's not included, it's less than. So it's you see, as you see, it's just similar to what we did in the previous problems, but it's like combined, it's a compound inequality. So if you want to show it on the number line, that -3 is like a close point, and then 39 over 2 is an open circle. So that's like I said, sometimes, I mean, really, it's kind of like in that interval notation, sometimes they put like here a bracket for the close point and a parentheses for the open circle. So that might be the case for different resources, just be careful. But it's the same, the bracket means it's included and the parentheses means it's not included. So next one, you can really try this problem yourself. And I can just say for this problem, let me just see if I can give you some. Yeah, this is the problem. So can you try this problem yourself? Pause the video and try this problem. I give you that hint that LCD is 20, so you're solving this inequality. So guys, in this problem, as you see, the LCD is 20. So you need to multiply here each term, each part by 20. So each one multiply by 20, and you simplify. So you distribute, that's like -15, 8 minus 40, and then 15. And you subtract 8. Again, the idea is you isolate t. But here you got -40 at the end. So if you divide by -4, as you know, you have to swap the direction, or you have to reverse the direction. So that changes to greater than in that case. And then you rewrite it. So -7 over 4 is less than t, and then t is less than 23 over 4, so that you can write it as an interval. Just don't forget, whenever you have a negative number that you're multiplying the inequality by, or dividing by a negative number, you have to swap or you have to reverse the direction. Okay, now here's another nice example. It's really a nice one. So you have a medicine with the temperature given by 10 degrees Celsius to 35 degrees Celsius in that interval. So we want to convert that into Fahrenheit scale. I mean, as you know, like this degree Celsius is just really common in Europe. Let's say you got a medicine from Europe, given in with that information. Now you want to convert it into Fahrenheit. So you need to know the formula, of course. That will be given in the problems, but you can check that the Celsius is given to be 5/9 times the Fahrenheit degree minus 32. So in this problem, our C value is between 35 and 10. So that means this really implies this 10 is less than. For C, you can write 5/9 times F minus 32, and that's less than 35. Now, we want to cancel 5/9, so you can multiply each one by 9 first. Or, I mean, to make it simple, you can directly multiply each one by 5/9. So it's like I have 5/9. I'm sorry, not 5/9, the reciprocal, 9/5. So it's like 9/5 times 10 is less than 9/5 times 5/9 times F minus 32, and then that's less than 9/5 times 35. So you see, I try to cancel that 5/9, and in this case 5 and 10 cancel, you got 2. These two will cancel directly, then these two will cancel, and I got 7. So what we have from here is that the Fahrenheit degree, it's like 18, is less than F minus 32, and that's less than 7 times 9, which is 63. And the final step is you need to just add 32 to all three parts. So it's like plus 32 and plus 32. So these two will cancel, and we got the final answer. So it's like 50 less than F, and that's less than simply 95. So the temperature that the range of the temperature is simply 50 degree Fahrenheit to simply 95 degree Fahrenheit. That's the range for the temperature for this medicine. So I hope this problem is clear. That was a good application. See, like you use compound inequalities. So we now come to the last part. When you have a quadratic inequality, I mean, this is really, I try to use the simple ones, but in these problems, what you do is I just put the steps in here. You find the intervals by solving the equation for the quadratic inequality, and then you find test values from each interval, and then you figure out whether that's positive or negative within each interval, and then answer the question. Like, you can try B yourself. You can pause the video after I solve this and look at part B. In the next page I'll give you that solution. But for part A, what you need to do is set one side equal to 0. So add 3 to both sides. So I have x squared minus 4x plus 3 greater than or equal to 0. So now you can factor this, as you see. I have two, I mean, if you set it equal to 0, that's fine. We can go from here. So I look for two factors of 3 with the sum -4. So it's like -3 and -1. Their sum is -4. So that works. So this factorization will be x minus 3 times x minus 1. And from here, once you set it equal to 0, you can see you got x equals 3 or x equals 1. So those are your boundary numbers. Now, this is, by the way, this is part A. So what you will do is you will form a table with x minus 1 times x minus 3. And be careful, you want that quadratic expression to be positive, because positive or I mean 0 really works, or sometimes you can just say combined as non-negative. So you don't want it to be negative. So once you look at this interval, you know the boundary values in 1 and 3. Don't forget that. So this is like negative infinity, that part is infinity. So we have two values like 1 and then 3, at which that becomes 0. Now choose a test value from each interval. From this interval, I can choose the test value to be 0. From this interval, I can choose the test value to be 2. And from here, I can choose the test value to be 4. See, you're going to test this over this expression. So let's do that. If I plug in x equals 0, what happens? So that's going to be 0 minus 1 times 0 minus 3. So that's going to be, you see, negative 1 times negative 3. I'm only testing the sign, so that's going to be positive. So I put a plus here. Let's test x equals 2. So in that case, I got 2 minus 1 times 2 minus 3. So that is, you see, it's like 1 times negative 1. It is negative. So I put here a negative. And if I have x equals 4, that's going to be 4 minus 1 times 4 minus 3. That's going to be 3 times 1. So you see that's going to be positive. So I put positive here. Now, as you can see, my expression becomes positive before 1 and after 3, but between that it becomes negative. So you can use this whole process for part 2 to solve part 2. So let's write our answer then. So if, let's just write it below. So we want if x is less than or equal 1 or x is greater than or equal 3, then we have x squared minus 4x plus 3 greater than or equal 0. See, we want that. We want x to be less than 1 or greater than 3. So how do we write this down? We write this as an interval. We just say that the solution set, now the solution set is simply negative infinity comma 1 with a bracket union 1 comma infinity. Union means, like this, union means combine. So those are separate intervals. So that's the solution set for this problem. So that union means combine. Oh, I'm sorry, I just put like 1. That should be 3. Sorry. So it's like negative infinity to 1 comma 3 to infinity, because that's when it becomes positive. So, or non-negative. Here that's like non-negative. Okay, here's positive, here's positive, here's negative. And now you can pause the video and work on this problem when it's less than negative 3. You will simply mimic the same thing. Yeah, now if you go to this problem, you see I just follow the same process, the same thing. But now I'm looking at the interval at which it becomes negative. So that happens between 1 and 3. So then the solution set will be 1 comma 3. And this is with parentheses because that's strictly less than. If it's like the previous one greater than or equal to, then you have to use brackets for the boundary values. So yeah, you may check the solution. And I hope this this part is clear. I hope these problems are clear. Thanks for watching. Bye.